So what I want to do here is I've got an exercise for you on matrix multiplication. It's one question with a couple of parts. I want you to read the question, pause the video, have a think about it and try it, and then come back and check your answer with what I'm going to present to you here. Here you go. So I'm giving you three matrices, A, B and C. I want you to find all the possible products of the three of them. So determine which ones can multiply together and what the solutions is. So pause the video and have a ping at those. Now remember, for two matrices to be multiplied together, if I have two matrices with the dimensions mn and np, these two here need to be the same. So the number of columns in the first matrix has to be the equivalent of the number of rows in the second matrix. So if I look at each of these and just look at the dimensions of them, A is a 2 by 3 matrix, B is a 3 by 2 matrix, and C is a 3 by 3 matrix. So if I then start to look at all the possible products, I can do AB, AC, and BC. If I just assume they all worked, they are the three calculations I could do. Now if I look at them, for A, I've got a 2 times 3, and B, I've got a 3 times 2. So the two of them would work. I could calculate the product of those two matrices. Good. So AB is one that I can do, and I'm going to do in a second. If I then look at AC, well, A is a 2 by 3, C is a 3 by 3. Remember, the important part is the number of columns here, the number of rows here. They match up, so I could do AC. One point to note, you couldn't do CA. The number of columns in C is 3, the number of rows in A is 2. That doesn't match up. That condition means that I cannot multiply the two matrices together. I'm then going to look at BC. Well, B is a 3 by 2, C is a 3 by 3. So the number of columns here is 2, the number of rows here is 3. They don't match up, so I cannot calculate BC. That is one calculation that we cannot do. So I'm going to just do AB and AC just to give you examples of how to do these calculations. So the first one, AB, we just have to remember to follow the steps that I told you about before. So I'm going to take the first row in A, and I'm going to say, right, the first row in A times the first column in B gives me element 1, 1 in my solution. So what that's going to give me is my first element is going to be given by 2 times 1 plus 1 times negative 2 plus negative 1 times 0. I've then got the first row times the next column, so times column 2, that's going to give me element 1, 2 in my solution. So that's then going to give me 2 times 2 plus 1 times 1 plus negative 1 times 3. Now that's me exhausted all possible columns that I can combine with this row, so I then move on to the second row here. So what I do is take the second row, multiply it by the first column. I'll have 3 times 1 plus negative 2 times negative 2 plus 1 times 0. And I then do my row combined with the next column, and I'll then have 3 times 2 plus negative 2 times 1 plus 1 times 3. And again, that's me now exhausted all possible combinations of rows and columns for this second row. Now there's no more rows, so that's all the parts I can do for my matrix. So that's me finished writing down the calculations. Now I just have to do it. Now it looks different because I've got rows of 3 and columns of 3 here, but remember, this is a 2 by 3, this is a 3 by 2, so whilst these elements match up and we can take the product of these two matrices, the solution, remember, is number of rows times number of columns here. So I'd be expecting a 2 by 2 matrix, which is exactly what I've got here. So now all I have to do is calculate each element and figure it out. So this first one here is going to be 2 times 1, so it's going to be 2 plus negative 2, so that's 2 minus 2 plus 0, So look at that, element 1, 1 is just 0. Never said you couldn't have that, just bear that in mind. This one here is going to be 4 plus 1 minus 3, so 4 plus 1 is 5, minus 3 gives me 2. Next matrix here is going to be 3 plus 4 plus 0. Remember, negative 2 times negative 2 is 4. So I've got 3 plus 4 gives me 7. Then this one here, I've got 6 minus 2 plus 3. So 6 minus 2 is 4, plus 3 is another 7. So there you go. That's the solution when I take those two matrices and I calculate the product AB. Now the next one was two matrices AC. So remember, 2 by 3 and a 3 by 3 matrix there. Because the number of columns and the number of rows match, I can do the product. And I'd be expecting a solution to have a 2 by 3 matrix. So what I can do is just do the exact same set of steps. So for matrix AC, I'm going to take the first row and I'm just going to go through and combine it with each column in turn. So first row is going to be combined with the first column there to give me entry 1, 1. So that's going to be 2 times 1 plus 1 times 2 plus negative 1 times 3. Sorry, negative 1 times negative 3. My apologies. Then I combine the first row with the second column to get entry 1, 2. So I'd get 2 times 0 plus 1 times negative 1. Then plus negative 1 times 2. Then combine it with the third column to get entry 1, 3. So I then have 2 times 3 plus 1 times negative 1 plus negative 1 times negative 2. Now that's me exhausted all my row and column combinations for this first row. I then move on to my second row here. And I do the exact same thing. Second row with the first column, then with the second, then with the third. So I'd get 3 times 1 plus negative 2 times 2 plus 1 times negative 3. So that there's entry 2, 1. Second row, first column combination. Then second row, second column combination. Gives me 3 times 0 plus negative 2 times negative 1. Then plus 1 times negative 2. And I then do second row, third column to give me element 2, 3. I've then got 3 times 3 plus negative 2 times negative 1. Then plus 1 times negative 2. And that's me now got all the possible combinations of rows and columns, so that there will give me my solution matrix to this. And again, it's just like we expected, it's a 2 by 3 matrix, which we were able to tell it would be just from this part of the question. If you ever get a matrix solution that you're not expecting like that, something's gone wrong. Go back and just double check your working. Make sure you've done it all right and combined the rows and columns appropriately. Now it's just a case of getting the solution. So a wee bit of maths. So I've got 2 times 1, so I've got 2 plus 2. I've then got negative 1 times negative 3. So I've got 2 plus 2 plus 3. So my first element is 7. I've then got 0, minus 1, minus 2. So that'll give me minus 3 for my second entry in the first row. I've then got 6, minus 1, plus 2, which will then give me 7. Is my third entry in the first row. Then I just do the next row. So I've got 3 minus 4 minus 3, so I'd end up with minus 4 there. I've then got 0 plus 2 minus 2, so that will give me 0 there. And I've then got 9 plus 2 minus 2, which will give me 9 as the final entry in my final row. So there we go. That's how we multiply two matrices together. As I said to you before, it is actually quite a straightforward technique and method to follow if you just remember to look at all the possible combinations of rows and columns and just do them turn by turn. Take your time, do it nice and steady. You'll get to a point where you can do it a lot quicker and a lot faster. Just nail the technique, and once you've nailed it, that should be you ready to rock and roll with any question that comes up of this format. So just remember the condition that we need to have in order to be able to calculate a product, then the type of solution we're going to get, so in this case a 2x3, and then the steps to do it. And then hopefully the final thing you need to remember is how to math. So how to do each of the calculations. I hope by now you could do 2 times 1 plus 1 times 2 plus -1 times -3. I'd hope by now you could do that. If not, we're in the wrong business. But good luck with that.